Welcome to an introduction to Amazon Route 53 Resolver. Hi, my name is Jordan Singer, and I am a software development engineer for Amazon Web Services. My main responsibilities are front-end development and data propagation. In this course, we'll start with an introduction and brief overview of Amazon Route 53 Resolver. We'll cover some of its features, give you a brief demonstration, walk through a use case before wrapping things up with some key takeaways. First, let's begin by covering some of the challenges of DNS resolution in hybrid environments and how Route 53 Resolver helps in addressing these problems. Before we can start talking about Amazon Route 53 Resolver, you must first understand what recursive DNS queries are. Let's say you have a web server running on an Amazon EC2 instance. You have registered your domain name, example.com, and configured Amazon Route 53 to route your internet traffic to your server. Now, if a user wants to access your website, they will open a web browser and enter www.example.com. The user's local machine will see if the IP address of the website is located in cache. If not, it will look to the user's internet service provider, or ISP, for the address. If the ISP does not have the address, it will send out various DNS recursive queries trying to locate the server hosting the requested website. The ISP is playing the part of the DNS resolver for the user. It's doing all the job of fetching the answer and giving it back to the user. During this process, the ISP might also query other DNS servers in the internet on your behalf for the answer. Once the address is found, the ISP returns it to the user's local machine, which stores it in cache for the next time the user needs to access the same website. When it comes to hybrid environments where your on-premises resources are connected to the AWS cloud via a VPN or an AWS Direct Connect link, a successful implementation goes beyond private network connectivity. It also requires internal naming, in other words, private DNS. You have an on-premises DNS infrastructure answering queries for on-premises resources, an Amazon Route 53 private DNS answering queries for resources in the AWS cloud. But in order to get the unified view of DNS across your hybrid network, you need bidirectional query resolution, which has not been possible until today. The ability to query your on-premises internal DNS zones from within their VPCs, as well as query Route 53 private DNS from your corporate data centers. Before Amazon Route 53 Resolver, you would have to implement a workaround to achieve internal name resolution for their hybrid environments. First, you would have to launch an EC2 instance in your VPC and configure your own DNS resolver on top of the EC2 instance. You would then configure your on-premises DNS client software to use the address of the EC2 instance as a resolver in the VPC. Every VPC that you wanted to serve and request private DNS queries would need at least one of these DNS resolver instances for high availability. This DNS resolver instance would act as the middleman between Amazon Route 53 and your on-premises DNS infrastructure. This workaround solution is costly to customers in terms of availability and maintenance. Customers found it cumbersome to maintain custom DNS resolver software running on EC2 instances, as the DNS software itself presented a patching and troubleshooting burden. Because of the difficulty of load balancing DNS traffic, customers typically provisioned a handful of large EC2 instances in each region to act as resolvers for all DNS traffic for their network in that region. Failure of a single instance would cause significant latency, as clients would be forced to wait for timeouts and retry against other instances. With all DNS traffic funneled through a small number of EC2 instances, large query volumes could cause throttling and result in failed DNS lookups. And there is a second workaround, which is to use AWS Directory Services Simple AD. This workaround also relies on an EC2 instance, which provides the ability to forward DNS queries in addition to its primary function as an actual active directory server. However, customers would have to purchase an additional AWS service, and Simple AD doesn't provide the ability to forward queries from AWS to on-premises, so it is not a complete solution. And now with Amazon Route 53 Resolver, you no longer have to worry about migrating complex DNS infrastructure into the cloud or building your own DNS resolvers to bridge the gap between the cloud and on-premises. Route 53 Resolver makes it possible to resolve DNS names managed anywhere in your network, from custom names in Route 53 private DNS to the default instance names provided by EC2, to names for on-premises resources managed by appliances in your data center. Amazon Route 53 Resolver offers a unified view of DNS naming across your hybrid environment, and the ability to control in a granular fashion how DNS queries are resolved within your network. Route 53 Resolver gives you the flexibility to define how DNS queries should be answered based on the domain name and where in your network the query is coming from. Now let's take a look at how Amazon Route 53 Resolver works and review some of its features. Amazon Route 53 Resolver uses a virtual device that is horizontally scaled, redundant, and highly available, called a resolver endpoint. A resolver endpoint is made up of at least 2 elastic network interfaces, or ENIs, with a private IP address that allows your DNS queries to flow between AWS and on-premises. The Route 53 Resolver endpoint enables you to privately connect your VPC and other supported AWS services to your on-premises DNS infrastructure, cutting out the middleman EC2 instance from the workaround solution we covered. It also provides a single predictable point of ingress for queries forwarded from on-premises to AWS. Queries are sent back and forth between the endpoint and the on-premises DNS infrastructure via either a direct connect or a VPN connection. When it comes to setting up Route 53 Resolver for your hybrid environment, AWS offers an intuitive configuration wizard to make things simpler. First, you will need to decide the direction of the DNS queries. Are you looking to only allow DNS queries to your VPC from an on-premises network, or to only allow queries to your on-premises network? You could also do both inbound and outbound queries. Next, you need to create the Route 53 Resolver endpoint by selecting at least 2 VPC subnets, suggesting it's spread across different availability zones. This ensures that if one availability zone is unreachable, queries will still be answered. And since the endpoint is really an elastic network interface, you can also assign security groups to your endpoint for extra security. The Route 53 Resolver endpoint provides a unique internal IP address in each selected VPC subnet, which we refer to as a forwarding target. In order to forward DNS queries from your data center to your VPC, you configure your on-premises authoritative DNS servers to forward queries to the forwarding targets of your endpoint. You will also need to configure a second IP address in each selected VPC subnet, called a forwarding source. Queries forwarded from your VPC to your on-premises authoritative DNS servers come from this IP address, which is a different IP address from the forwarding target. Finally, the last step is to create forwarding rules for outbound traffic from your VPC. A rule defines how DNS queries for a particular domain name or a set of domain names should be handled. Rules also let you configure conditional forwarding, which means sending queries for specific domain names to a different recursive DNS service at a particular IP address for resolution. For example, you may have 2 authoritative DNS servers in your data center, with the IP addresses 10.1.2.3 and 10.1.2.4, which are responsible for answering queries for the domain my.example.internal. You would create a rule that looks like the following on the slide. The endpoint ID refers to the Route 53 Resolver endpoint. Once you've created a rule, you apply it to a VPC to manage forwarding of DNS queries made by instances in that VPC. You can apply a rule to multiple VPCs across different AWS accounts, as long as they're all within the same AWS region. You can also associate more than one rule to the same VPC. You may want to do this, for example, if you have different name servers on premises responsible for different sets of domain names. If 2 similar names applied to the same VPC have conflicting rules, the rule that is most specific wins. For example, a.example.com is a more specific name than just example.com. Route 53 resolver endpoints can be reused across multiple VPCs in AWS regions and can be shared across AWS accounts. Large enterprises in particular have their infrastructure spread over multiple accounts. Route 53 resolver offers simple management of recursive DNS behavior across multiple accounts VPCs by means of a VPC peering connection. A VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using private IPv4 addresses or IPv6 addresses. You can create a VPC peering connection between your own VPCs or with a VPC in another AWS account. Amazon Route 53 Resolver integrates with AWS organizations to provide a unified rule set to be shared across different accounts via resource access management. Route 53 Resolver rules can be placed in a resource share, and a list can be created of accounts, OUs, or AWS organizations which can access those rules. You can grant access to a resource share to accounts both within and outside of your AWS organization. Once the resource share has been created, the set of rules in the resource share will be available for use to the specified list of accounts. Okay, now that we have seen an overview of the service and what it can do, let's run through a demonstration of Amazon Route 53 Resolver so you can see the service in action. When you first get to the Route 53 Resolver console, you'll be redirected to the home page if you don't have any resources. From the home page, you can see a little bit about how the service works, as well as some of the benefits and features to the service. If you ever have any questions about the service, here are the links to the documentation or refer to the help panel on the side. The first thing you'll want to do is to go to the wizard and start setting up your resources. On the first page of the wizard, you'll be able to choose the direction of your DNS queries. If you want queries into your VPC as well as into your on-premise network, choose inbound and outbound. This will then redirect you to the Configure Inbound Endpoint page. First, you have to specify a name. And then you'll have to choose a VPC to put the inbound endpoint inside your account. Next, you'll choose the security group that you want for this endpoint, which will control the access to the endpoint within your VPC. And then you'll have to choose the IP addresses you actually want the inbound endpoint to use. When choosing an IP address, you can either let Route 53 Resolver automatically select it, or you can choose your own IP address within the CIDR range of your subnet. And the CIDR range is shown above to make it easier for you to determine what IP address to choose. Next, you can add tags to help you organize and identify your resources. This is optional though. From there, you'll be redirected to a Configure Outbound Endpoint page, which is very similar to the Configure Inbound Endpoint page. The outbound endpoint will be the resource that is directing queries to your on-premises network. Again, you'll have to choose a name, a VPC, and a security group, as well as 2 or more IP addresses. The IP addresses can be within the same availability zone or in different availability zones. It's up to you. Lastly, you'll have to create a rule to direct certain domains to your on-premises network. When you are first using the wizard, this rule will use the outbound endpoint if you choose type forward. If you choose type system, that allows our DNS resolvers, which is Route 53 Resolver, to handle those domain names. You can choose VPCs to associate to this rule, although this is optional in the wizard and can always be done later. However, the domain name will not be able to be changed once the rule is created. Throughout the wizard, it defaults to the outbound endpoint created in the wizard. Next, if your rule is a forward rule, you will have to specify target IP addresses that the outbound endpoint will forward this domain to. Once again, tags are optional. This will bring you to a Review and Create page, where you can see all the information about the resources that you have created. If any of the information does not look correct, you can click the Edit button for that resource, or click the side menu to go back to another step. Once you submit, this will take you to a List VPCs page, which will show you the resources that a VPC contains as they are created. From here, you can see even more details about the VPC, like what rules, outbound endpoints, and inbound endpoints are inside or associated to that VPC. From here, you can edit and delete endpoints, as well as disassociate and associate more rules. The inbound endpoints list page will show you a full list of all inbound endpoints, along with their status, what VPC they're located in, and how many IP addresses they have. If you want more details about the inbound endpoint, you can go to the inbound endpoint details page. From here, you can see even more information about the IP addresses, which are the IP addresses that you target when you want to send queries from your on-premises network into your VPC, as well as tags for this inbound endpoint that help you locate and identify certain resources. You can also see the security groups and VPC that you have assigned this inbound endpoint upon creation. From here, if you want to add one more IP address for safety purposes and redundancy, you can do so. Again, you can specify your own IP address or let Route 53 Resolver assign one to you. You can also have a bigger edit view going to the Edit Endpoint page. From here, you are allowed to edit the name, as well as edit the IP addresses by deleting current ones and adding new ones, and adding new tags. Now you can see that the current IP address from the edit page is now deleting, as well as there's a new tag and the name has changed. The outbound endpoint list page is very similar to the inbound endpoint list page. You can see one additional feature, which is the number of rules that use that outbound endpoint. From here, you can also go to the outbound endpoint details page. This page is very similar to the inbound endpoint details page, except there is a column for the rules that use this outbound endpoint. The only additional feature is from this page, you can go to the Create New Rule page and have it default to the outbound endpoint that you were on. Lastly is the rules list page. You'll see by default that this Internet Resolver rule is automatically in your account. This is an auto-defined Route 53 Resolver rule that initially directs all traffic to Route 53 Resolver. If you want to override this rule, you would want to create a forward rule that forwards all queries, which is just the root domain, to your on-premise IP address. Now, whenever you associate this rule to your VPCs, you will be able to see that the auto-defined rule is overridden for that VPC. You can also receive more information on this page, such as the type of the rule, whether the status is shared through resource access management and who the rule owner is, as well as the domain name and the target IPs that this rule is getting forwarded to. Once again, tags are available to help you organize your own resources. From the rule details page, you can also go to the edit rule page, which is very similar to the edit outbound and inbound endpoint page. Here you can edit the name, you can associate or disassociate VPCs, and you can even edit what outbound endpoint the rule is using if it is a forward rule. You can also change the target IP addresses you wish the rule uses, and add tags if you want. From here, then you'll see that the rule is updating, so that the rule will now use this new IP address. Once the update is complete, the rule will now be forwarding queries to 9.9.9.8 instead of 9.9.9.9. The last link from this page is to take you to the Resource Access Management console. From here, you can create a resource share to share your rule with other accounts and view other resource shares. Thanks for watching the demo, and if you have any other questions, please refer to the documentation. All right, now that you have seen Route 53 Resolver in action, let's take a look at a typical use case and some key takeaways before we wrap things up. The typical use case for Route 53 Resolver involves multiple peered VPCs belonging to multiple AWS accounts in an AWS region. As you can see, the customer has a direct connect link between one VPC and their data center. You may have more VPCs connected to your data center over different direct connect links, but Route 53 Resolver only requires one direct connect link. All DNS query forwarding between your VPCs and data centers happens through the direct connect linked VPC, referred to here as the hub. If the rule specifies that the query be forwarded to on-premises, then the query egresses via the Route 53 Resolver endpoint in the hub VPC, traverses the direct connect link, and is answered by the customer's on-premises DNS infrastructure. Customers with workloads that leverage both the Amazon VPC and on-premises resources often need to resolve private DNS records hosted on-premises as well. Similarly, those on-premises resources may need to resolve names hosted on AWS. Using Route 53 Resolver, you can have bidirectional query resolution regardless of where the names are hosted. Route 53 Resolver rules can be created to conditionally forward DNS requests from your VPC to an on-premises DNS resolver. These rules can be shared across multiple accounts within a region by using cross-account resource sharing. I hope you learned a little something about Amazon Route 53 Resolver and will continue to explore other videos. I'm Jordan Singer with AWS Training and Certification. Thanks for watching.